All right, we're back for day 3, rules of exponents. Here we go. This last set of rules we're going to do today are very quick, very quick rules, but also going to be a little bit tricky, so you want to be careful with them. But here we go. We're going to develop what's known as the zero power rule, which is the best exponent rule there is, because once you recognize the zero power is in play, the question is basically done. We'll get that in a few minutes. We're going to talk about how to develop the negative exponent rule, and then we're going to talk about how to develop what we call the fractional exponent rule. Here we go. So the zero power rule, I'm going to show you a little pattern here and it kind of helps you out and figure out how the zero power rule works. And so if you guys have to do something like 2 to the 4th power, if you evaluate that, that's going to end up equaling 16. 2 to the 4th power just equals 16. All right, now if you use your calculator and do 2 to the 3rd power, 2 to the 3rd power is going to equal 8. 2 times 2 times 2 is going to be 8. If I do 2 to the 2nd power, that's going to be just 4, because 2 times 2 is 4. If I do 2 to the 1st power, I'm going to get 2, because 2 to the 1st power, or anything in the 1st power, just always equals the number itself. Okay, so you can always get that set. Hold on, make a little adjustment here. Okay, but what do you do when you get 2 to the 0 power? How does that work? All right, and what I would kind of have you guys observe and play with here is the following. If you look at the pattern going down the chart here, if I want to go from a 16 to an 8, what operation are you doing? You can sit and think about that, but kind of save you guys some time. If I want to go from a 16 to an 8, you could say, oh, it's minus 8. But if I do 8 minus 8, that's not going to give me a 4. I'm going to look for a rule that's going to get me down the list here. So minus 8 will work only for the first one, but not the next one. But what's another way to go from a 16 to an 8? All right, and maybe you're sitting there thinking, what if I divide by 2? If you do 16 divided by 2, that gives you 8. Now, if I do the same thing here, if I do 8 divided by 2, that's going to give me a 4. So, hey, here we go. The rule looks like it's working. Now, what if I go from a 4 down to a 2? Okay, if I go from 4 down to 2 and divide by 2 with that, all right, that's also going to work. So what if we make kind of the same thing happen for what we're looking at here? Okay, so sorry, I'm going to rewrite this just because it turned out pretty poorly. But if I take 16 and then I divide it by 2 to get 8, and then I do 8 divided by 2 to get 4, and then I do 4 divided by 2 to get 2, if I keep that pattern going where I'm just dividing by 2, all right, and I'm just dividing by 2, and then same thing again, if I'm just dividing by 2, what's going to happen every time? If I do that same pattern here and I divide by 2, what does 2 divided by 2 give you? All right, and the answer is 1. And this is a very nifty little thing that occurs, that anytime you raise a number to the 0 power, you're going to get an answer of 1. You can try the same thing with any power. If you do 3 to the 4th, 3 to the 3rd, 3 to the 2nd, 3 to the 1st, if you go 3 to the 0 power, it's going to end up equaling 1. How about if you have something like this? What if we do the rule we learned yesterday? If you have x to the 3rd divided by x to the 3rd, you might look at this and say, wait a minute, it's not top heavy and it's not bottom heavy, and they're the same. All right, well, if you apply the rule we learned yesterday, the quotient of 2 powers, you're supposed to subtract the exponents. So this would give you x to the 3 minus 3 power. Okay, but if I subtract those exponents, that's going to leave me with x to the 0 power. Okay, now if you look at this expression, these basically form a giant 1. Whenever you divide something by itself, you just get a giant 1. So x to the 0 power is just going to equal 1. So one of the greatest rules of all time for exponents is the 0 power rule, because anything raised to the 0 power is equal to 1. All right. Wow, I should back up the bus 1 second, but you're only going to have to worry about this when you get to Algebra 2 or Pre-Calculus. I do want to say, A is not allowed to equal 0. If you want a little extra, 0 to the 0 power is not defined. Okay, if you try that on your calculator, you're not going to get any kind of an answer. It'll probably give you like some kind of like one of those syntax things. So that little statement there just says A is not allowed to equal 0. You guys don't have to worry about that in this course. But when you take higher level math classes, 0 to the 0 power is not defined, so that's something you're just going to watch out for. Now, the rule just basically says any number other than 0 itself raised to the 0 power is always going to be 1. You don't need to overthink this. If it's raised to the 0 power, the answer is 1. So if I have 1/2 to the 0 power, don't even think about it. It's 1. If I have y to the 0 power, don't even think about it. It's 1. If you have this monstrosity raised to the 0 power, you see the 0 on the outside, people will panic looking at the inside, but if you see the whole thing on the outside is raised to 0 power, the answer is 1. All right, no reason to overthink it. Okay, let's take a look at some examples that might be a little more involved. If I have this 4x to the fourth over 9y to the fifth raised to the 0 power, jackpot, equals 1. If I have x to the 0 divided by y, be careful here, because now the whole thing's not raised to the 0 power. On the top, x to the 0 power is just going to be 1. On the bottom, you just have a y. Nothing's happened to the y, so I'm just going to leave that as just 1 over y. Okay, so that's what's happening with that. Okay, let's go to the next example. What about this? 4x squared to the 0 power times 5x squared to the second. Be careful. This piece here is going to use the 0 power rule because anything to the 0 power just equals 1. But now over here, you got to be careful. We got to do the rule we did a couple days ago. You're going to have to think of this as like 5 to the first. So 2 times 1 is going to give us a 5 squared, and then 2 times 2 is 4. So you're going to get x to the fourth power. So 1 times 5 squared is 25. So 1 times 25 is going to be 25, and then x to the fourth just comes down for the ride. So you get 25 x to the fourth power. But the key there, again, is just recognizing that this guy here is just going to turn into 1. All right.